show. Today I'm going to talk about the cloud bomb experiment, which we will be doing next week. The objective of this experiment is to determine the latent heat of vaporization of water using the cloud bomb equation for a range of temperatures and pressures. And they will have to provide the results using the steam tables in our thermodynamic. And here's the actual cloud prime equation, which is the differential of B saddle with respect to the temperature, which is HFG, which is the latent heat vaporization, divided by the temperature multiplied by the specific value. This is one way to get the HFG. There's another way, which is the ideal gas, which is exactly the same. The differential of B saddle with respect to the temperature, which is the HFG multiplied by B saddle over the temperature multiplied by the unit for the gas constant, R. And here's the BD plot, which we'll get when we get the data next week. We have the triple bond, the normal bond, and the critical bond. The critical bond is where the vapor and liquid coexist, and the triple bond where all three phases coexist: solid, vapor, and liquid. And we can see B side increases exponentially as the temperature increases, and the water only boils when the B side equals to the surrounding air pressure, which is PATM. And here is the list of the apparatus components. We'll need 1,000 milliliters flask with removable stopper, hot plate, heater, thermocouple, pressure transducer, which gets to convert the pressure into electrical signals to encode all the data. And we'll need a pressure gag, an air bleed valve, vacuum control valve, and a pump, and a water reservoir, and a computer system equipped with omega data. And here's the complete schematic for the experiment. We've got the hot plate, the flask, pump, the reservoir, and that's where we record the data. And that's the pressure transducer, and this is the air valve, and this is the air bleed. And we'll get the inlet and the outlet for the pump. The procedure, first we have to connect the data acquisition system to the thermocouple and the transducer right here. And then we'll have to open the PGAQ program, I don't know what that is. And we'll have to open a file, the Calcron file. And then we'll have to make sure the thermocouple and the pressure transducer are configured correctly. The pressure transducer should be on by default settings, and the thermocouple should be on low noise settings and at 25 millivoltage decade. And the sampling rate for the experiment must be set up correctly. The data should be encoded during the 5 to 15 minutes to get a reasonable number of data points. And we have to take data every 2.5 seconds to get a reasonable number of data points. And then finally, the DS should encode data for both pressures and temperatures. And the pressure and temperature readings should be close to the infinite condition. Setup and preparation, first we had to place the 100 milliliter glass flask with approximately 2 inches of water. And then the reservoir of hydraulic vacuum pump must contain sufficient water to cover both the inlet and the outlet. And then we have to close the vacuum control valve and open the air bleed valve here. And then we have to do leak test for the entire system. We can do that by closing the air bleed valve right here. And verify that the stopper is drawn in firmly, and then the pressure should drop in the beaker. Otherwise, then there's a leak in the system if it doesn't drop. And then the pressure in the beaker should remain very low at near zero. If not, then there's a leak in the system. And then for the actual experiment, we have to turn the vacuum pump on to increase the pressure in the beaker. we have to fill it with water, approximately 2 inches of water, and then we have to submerge the thermocouple about 0.75 inches into to the water, and then we have to plug in the hot plate and turn it on to boil the water in the beaker, and then we should get data or encode the data to get the PT blocks, and then after that we have to slowly close the line right here to afford the you have to slowly close the okay, so we have to slowly close this line to avoid any positive pressure buildup in the beaker, because we want the pressure in the beaker to be higher than the atmospheric pressure. Alright, and then we should get the data, and then beaker and the pressure should remain very low. If not, then there is a leak in the system, as I said before. We should have uncertainty in this experiment. Well, it depends like how we submerge the thermocouple. We submerge it more than 0.75 inches, we might not get accurate data, so we have to make sure it's 0.75 inches into the water. That's it. Any questions?